Today we're going to be looking at a pretty simple section, and it's dealing with area underneath a rate function. We're talking about rate functions again, like related rate stuff. No, it's way easy, so don't freak out. Let's think of a really simple example with just a simple rate function for maybe like a particle moving along a line. So suppose we have this constant rate function where the particle is just moving constantly 10 meters per second. And suppose we wanted to know the net distance. I mean, this is always positive, so we're just moving to the right 10 meters per second. So if we want to know how far it's traveled, we just look at the definition of a rate. A rate is simply, so R is simply the change in the distance, right, meters, just by definition. The change in the distance divided by the change in time. So that's why we have meters per second. So if we wanted to find the change in the distance, the net change in distance, if we're thinking about this kind of rate, you just multiply both sides by the change in time. So we do have to have some time interval that we're changing, and so that would cancel out, and then I would get the net change in distance. That will just be the change in time multiplied by the actual rate. So just by looking at the definition of rate, we can figure out the net change in distance. If the particle moves back and forth, we won't be able to figure out the total change in distance, but we'll be able to figure out the net change in distance from where it started over whatever time, which means like negative distance will cancel out with some of the positive distance. But for right now, let's just think about this. So what is the net change in distance of the particle from 0 to 6 seconds? Well, if we're traveling, hopefully this makes sense. If we're traveling 10 meters per second for 6 seconds, of course, we're just going to multiply, right? And that's what we have here. 10 meters per second times 6 seconds. So that's just 10 times 6. That would be 60. And the seconds cancel out, and we're just left with the change in distance would be 60 meters. Now, if we're looking at, and this is the whole reason why we have this title, if we look at the graph of the rate function, so that's the net distance, the net change in distance. So from 0 seconds to 6 seconds, the net change in distance is 60 meters. So, if we were to look at the graph of this rate, we will hopefully see something. So I'm going to graph it. And since our rate function is just a constant function, it will be a horizontal line. So that would be just something like that. That's R of t, right? It's just a constant 10 meters per second. And we wanted this from 0 to 6 seconds. So if I just take a look at that from 0, this is 1, 2, 3, 4, 5, 6. If I just take a look at this, the area here is 6 times 10. What? Crazy. So that's the basic idea. If you have a rate function and you want to get the net distance or the net change in the function, so like if this is meters per second, you want to know how many meters it's moved under a certain or over a certain amount of time, then you just get the area underneath the rate function. That's super important. This is the reason why the title is what it is. Area under a rate function equals net change. Net change in what? Well, it depends on what the rate is. If the rate is talking about meters per second, then it's the net change in meters. If the rate is talking about like books checked out of the library per month, then the area underneath would be the number of books, right? The net change in books. So let me write down a couple of those examples real quick. Well, let me just write down some things real quick. So that's something important to write down. The area under a rate function is the net change. It's just the title again. But net change in what? Well, let's see. Let's just write down what we just had. If we had a rate that was in meters per second, then the area underneath represents simply the net change in meters, the net distance, the net change in distance. If you have a different rate, say like I don't know, books per month, then the area underneath is just the net change in books over a certain number of months. So if you had the rate curve for books per month, then you get the area underneath that tells you the net change in books for over however many months. You need to know the number of months. If you had a rate that represented gallons per minute, what do you think? The area underneath, that's going to be the net change in the number of gallons. If the rate is always positive, then it's just really the actual change. But if the rate is negative, then it's the net change. We'll get more into that when we actually have some examples. But it's pretty simple. You just disregard the bottom one, right? And that's the units that you get. So we're going to be in gallons. So there you go. There's a little table for you. That's important. Let's move on. I think I want to do an example, but not in this video.